Hello everyone, my name is Ikra Ansari. I am from group number 324. So today we will going to study about the transport, and we will going to study about the passive transport, passive membrane transport. So the molecules that go across to the cell, it goes through the membrane, and we have active and a passive. So in this we will going to study about the passive. So the interaction energy of the promoter, the response of the membrane to the ligand addition may be gradual or sigmoidal, becoming in limited, all or non-transition. It is like it will be pass or it won't be pass. It won't be there in between. A phase transition. The formal model describe the action of the collikines and provide a qualitative explanation for a number of the facts, in particular for the fact that various related energy cause different maximum response of the membrane. The primary action of many drug is localized in membrane and is cooperative. So all the drug which has to perform the action and which used to do some like stimulation or inhibition, they have to do the action in the cell membrane. So the many drug are effective in very small concentration, down to 10 raised to minus mole, and are highly specific. So like highly specific mean if they will go into that receptor only for which they are gonna work. The effect of the drug on the membrane receptor is determined by the molecule recognition, but we still know a little about the nature of these receptors. So because of the receptor, there is a different drug formation. The main difficulty in building the molecular theory of the membrane transport and the reception consists in analysis the dynamic interaction between protein and the lipids. The membrane receptor presumably between the protein and the lipids. The change membrane receptor, primarily protein rhodopsin and the photoreceptor, change their conformation when bound to the ligand, which leads to the change in the depth of the immerse and the mobility of the protein in the lipid sea. So in this, our cell membrane is made up of the protein and the lipids. So from here, the ions, drugs, everything goes here to cross this lipid sea. It is made up of the head and the tail. The factor responsible for the cooperativity may be interaction of the floating protein upon their collision. The fluid mosaic model may serve as a basis for the molecular physics of the membrane. We may suppose that the properties of the membrane are largely determined by the electronic conformational interaction, like ECI. The local shift of the electron density that arise during the interaction of the membrane receptor with the ligand lead to the conformational change in the biological molecules. Of course, the transition of the electron and the ion across the membrane may be treated as the propagation of the conforms quasi particle consist of the carriers or the electronic charge, or as an electron density shift and the conformation displacement of the surrounding medium. The concentration of the membrane transport should naturally be started with the thermodynamics without the reference to the molecular dynamic, not so much explain physical phenomena as organize our knowledge, establishing the relationship between the physical phenomenal and their dependence on the parameter of the system. In particular case, the simplest a homogeneous membrane which is in contact with the two solution, the dissipation function inside the element, that is the dx of the membrane, may be written in the form of the it can be written as the d theta summation of ji and minus mu I. Thank you.